Welcome back to Plantopia. Plantopia is the plant health podcast of the American Phytopathological Society, and I'm your host, Matt Kasson. I'm an associate professor of forest pathology and mycology at West Virginia University. This is the second episode of Season 4 of Plantopia. Today I'm speaking with Dr. McCaghey, assistant professor of plant pathology in the Department of Plant Pathology at the University of Minnesota. Dr. McCaghey completed a BA in Environmental Studies at Hendrix College, an MS in International Agricultural Development at the University of California, Davis, and a PhD in Plant Pathology at the University of Wisconsin-Madison. As an early career academic, Dr. McCaghey has already built a diverse portfolio of research experiences focused around grower-driven research in soil-borne fungi and oomycetes. Before starting her current position at University of Minnesota in 2021, Dr. McCaghey had served as a postdoctoral research fellow at UC Davis, where she worked on southern blight of potato and diagnostics for vegetable and field crops. Dr. McCaghey has been the recipient of numerous fellowships, including a 2015 U.S.A. Research and Innovation Consultancy for Agriculture Fellowship, a 2017 Borlaug Fellowship through the Borlaug Summer Institute on Global Food Security, a 2019 WI Science Scientific Teaching Fellowship, and a 2020 USDA NIFA Postdoctoral Fellowship. Since 2017, Dr. McCaghey co-authored numerous impactful publications on Sclerotinia stem rot and southern blight, including papers in Vital Frontiers, Plant Disease, PDMR, Tropical Plant Pathology, and Frontiers in Plant Science, along with some 24 published technical reports. In addition to her research credentials, Dr. McCaghey also has an impressive list of teaching experiences at the University of Minnesota, the University of Wisconsin-Madison, and UC Davis, including ID and management of agronomic pests, ecology, epidemiology, and evolutionary biology of plant-microbe interactions, and fungi magic, to name a few. Dr. McCaghey is an active member of APS and serves on the Soilborne Pathogens Committee, the Mycology Committee, and served as former chair of the International Year of Plant Health Social Media Working Group. She has co-organized, moderated, and served as a panelist for various APS webinars and poster sessions at the APS annual meeting, Plant Health. Megan, it's a real pleasure to welcome you as my second guest on Season 4 of Plantopia.
Thank you so much for having me. I am really excited about participating in this podcast and look forward to our discussion today.
Me as well. It's great to have a chance to have a more detailed talk about your research experiences in your career. Now, based on your educational background, one might assume that you're from Arkansas, since you not only started your education and your career path there, but you spent several years after graduating from Hendrix working for AmeriCorps, the Southern Sustainable Agricultural Working Group, and then the Ozark Natural Sciences Center. Are you an Arkansoier?
I think I would consider myself an Arkansan. I lived most of my adult life in Arkansas. I was born in West Texas, and I've spent time moving around throughout graduate school and my career, but certainly spent most of my life in Arkansas.
Well, tell me a little bit about your early life there and how those first formative experiences, maybe outdoors or in agriculture, shaped your career ambitions.
Sure. Yeah. So I didn't come from an agricultural family. And really, when I was younger, I wouldn't have known or thought that I would become involved in agricultural work or in plant pathology. I didn't even know what plant pathology was at the time. But I had an early interest in nature. I spent most of my time in the summer during the day out catching lizards and snakes and romping around in creeks. And so I was very interested in the natural world from a very young age. And I was also interested in the humanities and in theater. And so in college, I was an environmental studies major. I went to college at Hendrix, which is a small private liberal arts college in Arkansas. And I went there in part on a theater scholarship. And I was taking classes in politics and anthropology and sociology, but also taking classes in ecology and in environmental economics. So I had this really interdisciplinary background in botany and zoology. So I at the time thought I had conflicting interests, but then I took a class called Food Culture and Nature, where I learned a lot about the societal importance and cultural implications of agriculture and of food, and came to think about agriculture as this way to really meld my interests in biology with being able to have a human impact. So that's where my interest in agriculture really sparked.
I saw that you served as an instructional support person for a class called Algae and Fungi while you were there. Was that also a catalyst for your interest, or was your interest already developed and that was just more, you were hungry for more information?
Yeah, so that was a way for me to learn more about the laboratory side of science. And I was helping with culture preparation and media preparation. So getting the lab set up for this particular class. I had taken botany and really enjoyed it. So through my botany instructor, I had the opportunity to aid with this class. And I was also a caretaker in the greenhouse, watering and taking care of plants that were used for instructional purposes. So that was probably my first hands-on experience, I would say, in plant science. My research actually during my undergraduate degree was on coral snake mimicry, so a very different direction, but this was my first applied experience with plants and plant science, you could say.
I love hearing the fact that you came in a theater major, and I don't say that jokingly because I think about how many of us as scientists have strong passions or hobbies as artists. And I think that what Einstein said was correct. He said, after a certain level of technical skill is achieved, art and science tend to coalesce in plasticity, aesthetics, and form. The greatest scientists are always artists as well. And I think just having that ability to see the world through an artist's eyes helps you to be a more creative researcher. Do you think that's true?
Yeah, I'd like to think so. I think that's one aspect of my job that I really enjoy is the creativity of being a researcher. And when you write grants, it's really fun. You get to come up with new ideas that are based off of a foundation of information that the community has generated and think of different methodologies to test the hypotheses that you come up with. And communication is also a creative endeavor. So much of what we do, both as researchers and as instructors, is we communicate information. And so developing engaging ways to communicate that information and coming up with the storyline of our presentations, I would say that's also a creative process. So I really like that idea. Yeah, I think that although I don't actively participate in the arts at the moment, I think that having that background is really helpful and indicative of kind of my interest in creative endeavors and idea generation. Yeah.
Absolutely. And I think it's also encouraging for students that may have a less traditional path and they think that they're an outsider and that they may not be able to offer a perspective that's helpful. But seeing you have come through that kind of non-traditional path, they say, oh, here I see myself. I can identify myself in her. So that's great. One of the things I was really impressed with looking over your CV was your extensive travel history. New Zealand in 2008, Costa Rica 2009, Ecuador 2009, Norway for a study abroad, South Africa 2015, maybe Chile 2018. I'm not sure if that was in there. This was obviously intentional. And I get a sense that some of those early experiences might be associated with the society and culture emphasis of your undergraduate degree. Is that accurate? And before I let you answer that, what were you hoping to gain from these experiences? And do you think that they helped to further solidify your interest in international agriculture and agriculture as a whole?
Definitely. One unique aspect of the university that I attended, or the college I attended in my undergraduate, was they had a program called the Odyssey program where undergraduates could apply for funding to be able to travel abroad and participate in projects abroad. And that was certainly an aspect of my social cultural emphasis of my undergraduate degree and my interest in agriculture. So when I went to Costa Rica, for example, we were surveying coral snake mimics in rainforests in Costa Rica, but I was also able to incorporate objectives to be able to explore coffee and chocolate production and to tour coffee and chocolate farms while I was in Costa Rica. My college really encouraged this interdisciplinary way of thinking. And then, so in New Zealand, I was working with habitat restoration. So I was planting native plants and doing some dirty work as well, cleaning out rat traps because they were trapping rats, which are a threat to native birds. So yeah, I had the opportunity to travel in college in a way that I hadn't previously, and going to school in the same day and in the same state. This was really perspective building to me. And also the experiences I had traveling to Costa Rica and engaging with food production was formative in my interest in wanting to continue on within agriculture and potentially do research in agriculture. So my master's was actually in international agricultural development. I went to UC Davis after learning that I was interested in agriculture and potentially wanted to work in international settings. And then while at Davis, I had the opportunity to travel to South Africa towards the end of my master's degree, where I was working on a U.S.A. project and surveying maize diseases throughout KwaZulu-Natal. And I was working closely with growers, members of industry, seed companies that we were collaborating with, and I was working in the laboratory of Dr. Dave Berger. This was very formative in my interest in moving forward with plant pathology research during my PhD.
Great. Yeah, I've also been to KwaZulu-Natal in South Africa in 2019, and what a beautiful area and what a unique spot there on the Indian Ocean. I'd like to keep talking about your master's work at UC Davis and generally about the master's degree. My conversation with Jim Bradeen talked a little bit about masters and how they can serve as an important stepping stone that allows one to determine if pursuing a PhD makes sense. Did your master's allow you that kind of introspection? And before I give you the mic, I'll also note that, like you, I started off at a small, less than 1,000 student private college and went to progressively larger and larger institutions as I worked my way up to my PhD. And I wonder if that factored in your decision to go for the master's first and then the PhD.
My school was bigger by 200 people. So we had 1,200 students when I started. And then I think enrollment is currently around 2,000 now. Yeah, it was a small school. And the research that I did was survey-based. I didn't have any lab-based research experience. And really, I didn't understand what that meant. I didn't know what a graduate research assistant was or what a teaching assistant was. And I think I entered my master's program with quite a bit of naivety, if you will. So when I was there, I figured that I would be assisting with teaching classes to pay for my master's during the entirety of my studies. And I didn't go in with a research position. I knew I was interested in pursuing research potentially at some point in life, but I didn't understand that I could pay for graduate school that way. While I was there, I applied for a position that I saw advertised with the Agricultural Sustainability Institute. And Dr. Kate Scow is a soil microbiologist, was the person who advertised this position. And so through that position, I was able to explore research questions on the impact of soil amendments on processing tomato, agronomics, and disease and soil properties. And so that's really how I learned the process of research and how to develop a research project, that things don't always go as planned, and how to regroup and rethink and adapt whenever you have field projects. So that's really what piqued my interest in research and where I got my feet wet with plant pathology. And then I took classes during my master's in plant pathology. And I also took a mycology course taught by Dave Rizzo. And I learned about the amazing diversity of fungal pathogens and their impact on food security. So being in international agricultural development, I was really interested in food security. And at that time, I learned that fungal pathogens contribute anywhere from 10 to 25% of crop loss in the field. And it's a similar amount in post-harvest environments as well. So learning about the impact of fungal pathogens made me very interested in continuing on with research related to those pathogens.
I think it's fair to say that sclerotinia and stem rots they cause have received a rather disproportionate amount of your time and your students' time over your career. But recent work on southern blight and Phytophthora sojae suggests you've opened your arms to other pathogens outside the Ascomycota. So tell me about your current work on these pathogens and you can be selective or exhaustive. What host systems are you working in, and what's your lab investigating?
Sure. So I was working with southern blight in California, which has really become more and more of a problem as California has experienced an increasing frequency of heat waves during the summer months. There hasn't been a ton of southern blight work with potatoes because in most potato growing regions, they don't have the same heat intensity that is experienced in California. California produces the largest share of organic potatoes, so there are a lot of fresh market potatoes that are grown in California, in the Bakersfield area in particular. And in Bakersfield, they have really scorching hot summers at times and really hot springs as well. And increasingly, as mentioned, they're experiencing heat waves and during earlier times in the growing season. And so this has been a very difficult disease for growers to manage. It kind of sneaks up on them at the end of the season when temperatures are the highest, when potatoes are ready to be pulled out of the ground, and the consequences are pretty brutal. It creates a nasty tuber rot at the end of the season, as I became very familiar with digging up tubers and sorting them by hand for their rot. And so with this particular disease, we were really taking a variety of approaches to try to help growers have more informed management of the disease. So we were looking at chemical applications, so trialing various chemicals and looking at different application timings of those chemicals, amendments to the soils, and also working to develop forecasting models so growers have a better understanding of when their fields might be at risk of southern blight. And some of that work is still continuing. I still have many of those data sets in my hands that I'm working with Cassandra Sweat at UC Davis to write up and to develop management guidelines that growers can use. So some of the interesting findings that we were able to glean from that work is that there are actually some effective chemicals that can be applied at the end of the season. In particular, one that we found that was useful for managing southern blight is ammonium bicarbonate, which we think of as a baking ingredient and is not very expensive for growers to use in their field. But when applied at the end of the season, around when the tubers are desiccated, it can help to manage the disease. We also found that applications of chitin through crushed up crab shells was able to help reduce the persistence of sclerotia and decrease disease in treated plots. Those were a few of the findings from that work.
That's really interesting. Now, on the topic of southern blight, if those of you that don't know southern blight, we're talking about Agrothelia rolfsii. Is that the correct Latin binomial? I know taxonomy is changing all the time.
Or Sclerotia rolfsii, yeah. Depends.
Yeah. I don't think you could really appreciate this disease and this pathogen unless you've smelled it decaying. Whether it be a tuber, we do an experiment in my general plant path class where we inoculate pumpkins. And by the end of the semester, let me tell you, the smell of a pumpkin that has southern blight is not very inviting. And of course, one of the other considerations, and probably worth bringing up here, is that a lot of the fungal pathogens you've worked on have pretty broad host ranges. What crops are resistant to southern blight or tolerant of southern blight and don't cause the kind of devastating rots that you see in tuber?
Yeah, that's a great question. So you're right. It can infect over 500 different hosts. Dicots generally tend to be pretty susceptible to Sclerotium rolfsii. While I was in California, I saw a processing tomato field that was pretty well decimated by southern blight. Sunflowers. We also saw it in onion fields, and I was working in potatoes. Gosh, yeah, a wide array of crops can be infected by Sclerotium rolfsii, unfortunately. Monocots, such as rice and corn, aren't infected by Sclerotium rolfsii. So there are other crops that may be used in rotation to help to reduce the inoculum load. Same with Sclerotinia. Here in Minnesota, we have a wide array of host crops such as soybean, dry bean, sunflower that are susceptible to Sclerotinia sclerotiorum. And I would say there may be fewer rotational options for Sclerotinia here other than there's corn, right? But in California, where you're working with diversified vegetable systems, maybe there would be more opportunity for rotation than in a field crops environment like we have here in Minnesota.
Okay. So on the topic of sclerotinia, of course, your students, it seems, are currently working on problems in and around sclerotinia based on what I could see on your CV. But do you want to tell me what active projects you have going on sclerotinia?
Yeah, sure. We do have an array of projects in sclerotinia. The 2 graduate students who are in the lab are focusing on sclerotinia. One that I think is really interesting is in collaboration with the soybean breeder, Dr. Aaron Lorenz, here on campus. And we are looking at the interaction of plant architecture and white mold development. So sclerotinia has very specific conditions that are required for the formation of the apothecia, which is the fruiting body that produces ascospores that then land on susceptible hosts. So we tend to see sclerotinia becoming a problem in fields when we have closed crop canopies, and there are specific wavelengths, particularly UVB light, that induce the formation of the apothecia or the cup of the fruiting body. And so Aaron Lorenz had 150 different lines with various architectures that we have been evaluating in the field over the past couple of summers to look at both the quantity and the quality of light that is received at the ground level at various distances from the base of the plant. We're also scouting for disease, and we're simulating light conditions in a laboratory environment, and we're phenotyping these plants as well. So looking at characteristics such as time to canopy closure, leaf shape, branch angle, to try to better understand which attributes of the plant might be contributing to apothecial formation and disease development in the field. So I think that's an interesting pathogen ecology question that the master student, Alicia Hirschman, has been able to pursue during her time in my lab. And then I have a PhD student, Xuanfu Wang, who is investigating aggressiveness determinants of Sclerotinia sclerotiarum. So sclerotinia can be a very aggressive pathogen. It can girdle the stem of soybean plants, which leads to vascular wilt and plant decline. But not all isolates, we know from previous work conducted in the Smith lab and elsewhere, have the same amount of aggressiveness. So some may have minor lesions that don't necessarily lead to that vascular wilt and decline. So Xuanfu is interested in understanding and identifying what these aggressiveness determinants that are conserved across crop species, what those aggressiveness determinants are. So he's using transcriptomic and genomic approaches to be able to identify what makes certain isolates consistently aggressive versus mildly aggressive across crop species. He's also working to develop tools that breeders can use to screen for resistance, for representative resistance reactions across crop species. So he's currently working with our isolate collection to develop a subpanel of isolates with consistently low, medium, and high levels of aggression on different crop species that breeders can use to challenge plants and to observe a representative resistance response.
Great. Well, obviously, when you're working on an important crop like soybean and other important agricultural crops, often it's not just one disease you're dealing with. You're dealing with rots and leaf spot diseases and wilts. And it's difficult because you put all this effort into understanding which lines are resistant or tolerant of pathogen A, but pathogen C sneaks in there and takes out your whole line. And it's a complicated world. So we know what you're up to in the research front, and anyone who's spent 30 minutes kind of reading in between the lines in your CV, it's clear that you're a natural-born educator. You're currently teaching ecology, epidemiology, and evolution of plant microbe interactions. You've also recently co-instructed a course called Fungi Magic. You've served as a lab instructor for Intro to Plant Path and Plants Get Sick. You've also taught at your previous institutions. You were a Wisconsin Science Teaching Fellow, or U.S.A. Teaching Fellow. Is what you're teaching now what you see yourself teaching and what you want to be teaching? And what else would you want to teach as you have the bandwidth?
That's a great question. So I think my current teaching docket is pretty satisfying in that I get to teach a plant pathology course for non-majors called Plants Get Sick Too. So I get to introduce undergraduates to plant pathology. Many of them have never heard of it. They may have signed up for the course because they thought the title sounded interesting, but they still may not know what plant pathology is whenever they start the class. So that's been really rewarding, and it's a great chance to evangelize, if you will, about our field and the impact of our field and the impact of plant pathogens. And it may be the only science class they take. So it is a biological science credit within the College of Liberal Arts here on campus. So we have students who are computer scientists, students who are design students. So it may be the only science class that they take. So it's really interesting. And I feel like it's important to teach them about the scientific process and basic concepts in biology that they can use when they are interpreting information in the media or thinking critically about an issue related to science that they may have exposure to or maybe a political topic of interest. And then I'm also teaching a graduate level course, as you mentioned, ecology, evolutionary biology, and epidemiology of plant microbe interactions for the first time this semester. And that course really stretches me to investigate what the newest research is in pathogen ecology and epidemiology, and have engaging discussions with graduate students who sometimes make me have to go a step further in terms of thinking about the information that I develop or look up the clarifying question, especially since this is my first time to teach the course. So it's a great balance of teaching. The Fungi Magic class that you mentioned, that was for the May session during a Public Health Institute here on UMN campus. That was really fun too, because I was interacting with graduate students outside of my field and learning about how they engage with questions related to mycology and providing an introduction to our field. So that was interesting. It was only a week-long course. And I think thinking into the future, I would be really interested to do more interdisciplinary teaching, potentially with the vet school or the medical school related to maybe mycology in the context of global health broadly, like plant, animal, and human health. UC Davis has a global disease biology program that's been really successful, and that sort of interdisciplinary teaching excites me, and maybe that's something I could find room for in my schedule to develop and to teach in the future.
If one thing is clear, that you still have decades of teaching and research ahead of you, so slow and steady wins the race.
Yeah.
I saw that you had served as a guest lecturer in that same class you're teaching this semester. And it brings me to an important point that I think it's worth talking about, is that you haven't been an assistant professor for very long, since 2021, correct? You were a pandemic postdoc, and the first years of your life as a PI and professor have been no doubt impacted by COVID-19. How have those experiences changed the way you view and approach teaching, mentoring, networking? Because clearly all those things have been impacted for you, including the interview process for the job you currently hold. Do you want to talk about any of that?
Sure. So I think COVID-19 impacted all of us in various ways. I started my postdoc right after my PhD graduation in the spring of 2020. I had a few months of normalcy before everything changed. And the PI I was working with, Dr. Cassandra Sweat, did a really great job of thinking of systems and mechanisms to keep work moving forward. And so I do think it was really motivating, maybe inspirational is the word, to see how we as a lab were able to adapt to circumstances, not without inconvenience, right? Like many folks, I was culturing fungi on my kitchen table, and my husband wasn't a fan of the rotten potatoes I was storing in my garage. It wasn't convenient, but we made things work. We had field plans where we were able to maintain certain distances from each other as we moved through the field, and we had everything mapped out with arrows. So folks had an understanding of where they would move as they were sampling various plots. So that experience really, I think, was helpful for just knowing that things change, things don't go as planned, and we as researchers can be adaptive. So maybe there was some resiliency training there, but ultimately we were able to get the work done. And my interview for Minnesota was completely remote. I had never been to the Twin Cities when I accepted my position. As we were looking to move here, we were doing our home search all online with videos on a cell phone from a realtor. It was not a typical experience, but I do think the department did a good job of ensuring that I had individual conversations with various groups here in the department. So I had meetings with staff, I had meetings with students. I still had the same meetings I would have in person. Maybe when I turned my camera off, I could put my head down on my desk and take a few breaths. I don't know if I would have been able to do that in person. And I had the comfort of my own home when the day was done after my interview questions. And then when I got to campus, I would say a difference that others may not have experienced to the same extent during non-COVID years was just that it was a bit quiet on campus when folks weren't attending in-person meetings. So that changed a lot in the past, and folks are making an effort to swing by each other's offices and check in, and those informal conversations are starting to happen. But when you're a new PI, you have a lot of really basic questions. How do you work the printer? How do I clear these purchases that I made without having it sent back to me 2 or 3 times? And so I think there were inconveniences of just not having those interpersonal, casual conversations you would have had otherwise. And the community part of our profession that so many of us really enjoy, I think that took a hit during COVID time without in-person meetings and whatnot. But it's amazing to see how so many people were able to adapt in many ways.
Yeah. One of the things I saw is that a number of people took on postdocs remotely. And remote postdoc has become a thing that's still around. And I'm a big fan of it, to be honest. I think that this idea that we need to uproot our families and our lives and move 2,000 miles every 2 years is ridiculous. I understand that sometimes we only have one option of where to go, but it's nice when you're doing, say, bioinformatics or genomics that you're able to do that remotely. And so I'm sure that even though yours in particular was more of an applied and on the ground, your generation is more willing to accept that kind of remote work, and that you don't always have to be in the same place at the same time to do great work.
Right. And it opens up opportunities for others who may not be able to participate outside of COVID times. I'm thinking about the committee meetings we had last year for plant health. I recently had a baby and I was too advanced in my pregnancy to travel for the meeting, but I was still able to attend the committee meetings because they were remote. So I think having that as an option it opens up opportunities for folks to participate that otherwise wouldn't at times. And I'm also thinking of one of the first grower meetings that was remote that I attended for the California Tomato Research Institute, where we had people from other countries that were participating in what is usually a relatively small meeting, but this was a very large meeting with folks from all over the country and, some international participants because they just had to click on a Zoom link.
Yeah. And you mentioned having a child, and we'll talk on that in a second here. I was thinking about just giving guest seminars. I have 3 young boys, and I'm more inclined to give a virtual seminar in a department across the country than I am to go visit, even if they would pay for it. I'd rather not be away that many days because of the inconvenience to my spouse and whatnot. And one of the things I enjoyed as being a guest on Plantopia was this opportunity to put down the pipette and the petri dish and talk about what makes us human, about balancing academics and kids and dual careers. I know that you mentioned you're a new mom, and with being a mom, you have a lot of spinning plates. You're a new PI, you're writing grants, you're mentoring students, you're raising a child with a partner, which means your life is complex. How's it going? And maybe what advice do you have out there for early career scientists, particularly early career women that are interested in this field but feel that they don't have, or they're worried they may not have the support to raise a family and do the job you're doing?
Yeah, I think it can be challenging and everyone's circumstances are different. But for me, I'm finding a new routine and a new path forward in my academic career for me to be able to have a really rich work life and also home life. So I found that if I have a little bit of extra work to do at the end of the day, for example, my daughter goes down between 7:30, and that's my window to get things done. And so for me, in some ways, it's made me a more efficient worker because I know I only have X amount of time to get things done because I want in my free time to be able to spend time with my family. It's not just my time anymore, right? It's time that belongs to my daughter and to my family. So in some ways, I feel like it has made me a more efficient worker. In terms of preparing to be gone from the lab so that things would keep moving forward, I did quite a bit of work up front. There was a document that I generated to the lab called What to Expect When Your PI is Expecting that I adapted from a document I found online just to make systems clear for who to contact in the event of X, Y, and Z. This is when I might be available. This is when I won't be available, so that they have an idea of just what things would look like. And I helped to establish meetings before leave so that they knew who they could go to for mentorship in my absence. And many of them have existing mentors, right? They have graduate committees or they have collaborators on projects. So it was just made clear to those collaborators that the student may be coming to you for additional assistance or help while I'm out. I'm certainly still figuring it out, right? I feel really lucky in that my daughter, I shouldn't even say it out loud, but she's pretty much sleeping through the night right now. She's just about 5 months. She turns 5 months old tomorrow, and she wakes up once early in the morning and then goes back to sleep until about 7:30. So I feel lucky. I think if she would have been waking up all night while I'm teaching a new course, it would have been even more challenging than it is currently. But yeah, so in some ways that's made me a more efficient worker, and in other ways it has been a challenge, but I haven't noticed a big dip in what I've been able to do or accomplish. And in fact, I'm often excited to be at work and doing something different than when I'm at home and interacting with my daughter, and vice versa. I'm excited to get home and to spend time with my daughter. And I look forward to, in the future, introducing her to the natural world and to fungi and to the things that excite me and energize me. So yeah, it's been challenging, but also enriching and exciting. And gosh, I still feel like I have so much to learn. A whole new area of literature, right? Not just about what's coming out in terms of Soilborne fungi research. I'm also looking at articles about when to introduce solid food to your kid and what the implications are for doing it at different times and different ways. So yeah, It's been interesting.
I think the bigger point here that I take away from it is that, one, I recognize that there are other early career scientists that can't have children or that don't want a family, and that's certainly okay. I think having kids, though, forces you to prioritize kind of work-life balance in a way that's more immediate than it would be otherwise. But I think I really like the fact that I'm able to try to have more of a work-life balance for the sake of my kids and my spouse, because like you said, you want to spend time at home with your family, and doing that and mirroring that to your students is really helpful because it shows them, yes, I expect you to get your work done, but I also expect you to take care of yourself, your mental health, to have a life outside the lab. And I think a lot of PIs my age and younger, your age, are recognizing that work-life balance is so important because whether they want it to be this way or not, our jobs will take every ounce of our energy from us and more if we'll allow it. And it's important to not allow that to happen.
I think that is an important message. And part of my thought was, is this the right time? When is the right time? I knew I wanted to start a family, but during my PhD and my postdoc, it would have been really hard. And now as a new professor, it would be really hard. So it was just, when is the right time? But I've come to accept there never is a perfect time. And I've been able, even as a new faculty member, to adjust and to be able to accomplish both of these really important aspects of my life, having an enriching career and having a family. And so I think if that's something that's important to you, you should do it. It's important to move forward with that aspiration.
We're getting close to the end of our time together, and I wanted to open the floor for something that you'd like to talk about that maybe we didn't address in our conversation. I'm happy to discuss that.
Sure. I think mentorship has been a really important aspect of kind of my career development, the mentors that I've had and how it's shaped maybe my mentoring approach.
I think mentorship is really important. Finding the right mentor and recognizing when you don't have the right mentor could have a profound effect on your career path and your career trajectories. Yeah, tell me about some aspects of your own mentorship that you feel like you'd like to, or maybe have already adopted in mentoring students of your own, whether they be undergraduate researchers or the 2 grad students you have currently in the lab?
So one question you asked earlier was also about having a master's degree and what that maybe lent to my path. And I think both in my master's and in my PhD and in my postdoctoral research experience, I gleaned little pieces of information or models to use in mentorship for my lab and for my students. And at each stage, I was mentored by both a basic researcher and an extension faculty member, which really fueled my interest in doing translational, grower-driven research. But my mentors had very different styles of mentorship at each stage. For example, at Wisconsin, I had a mentor, Damon Smith, who was really proactive in having us involved with field days. And we engaged with growers and gave presentations in the department, often talking about our research. And then Dr. Kabaj, he had very structured, regular lab meetings. And then my postdoctoral researcher, Dr. Cassandra Sweat, had detailed lab expectations that we were provided and regular reviews with her students and staff. We also had a manuscript writing workshop to help generate manuscripts from the lab and to give each other peer reviews and feedback. And so these are things that I've gleaned and taken from engagement with my mentors throughout time. And so just as a new PI starting off, having had those experiences and those tools was really helpful to me as I engage with the undergraduates and the researchers and the students in my lab. I hope that I can model some of those systems and some of those interactions that I had with my mentors. For example, we had a field day this summer with the Soybean Research Center here on the St. Paul campus. And Alicia and Xuan Fu and Dr. Markham, our lab's researcher, all presented about their work and interacted with growers and got feedback about the work, and were able to learn new questions that the growers had that they were interested in having us potentially pursue. So I think having those interactions with growers was really important. And then we have lab meetings where we present our research and where we learn new skills. We have skill days where we learn new skills from each other, because we're really not taught how to mentor formally, right? In academia, it's such a big part of our job, but it's not like we have classes in mentorship, just like we don't have classes in the administrative work that we do. But so much of what we do is mentorship and service and administrative. And yeah, I think having had the experience I did in my master's, my PhD, and my postdoc, all of those were really helpful in developing my mentoring philosophies and systems.
Great, thank you. I would argue that learning to pull rats from traps in New Zealand probably prepped you for administrative loads that you deal with at the university level. But it's been great talking to you today, Megan, and I really appreciate you taking the time to chat with us about your career and your career path. And we look forward to talking to you in the future, but thanks again for your time.
Yeah, thanks so much for hosting me. This was a lot of fun, and I look forward to keeping up with the podcast in the future.
Great. We've just heard from Dr. Megan McCaghey, Assistant Professor of Plant Pathology at the University of Minnesota. I'm Matt Kasson, host of Plantopia. Thanks for listening.